Okay, good morning, everyone. I want to welcome you to another Theory of Statistics class. Today we got to important derivation. This is the first one, and this is the second one. But before I go into the derivation, of course, I'm going to say this. You know, this is what we're going to do from next week, the chapter 7, and it's going to be the last chapter in the semester. We're not going to go beyond that. Coming to this, I want to walk you through how an important distribution in statistics is being derived. There's a distribution that we call T distribution. We use T distribution whenever we want to conduct a t-test. Has anybody heard about t-test? Okay, thank you. You know, if I want to conduct a t-test, I need a t-distribution to figure out the p-value to be able to take decision. Without a t-distribution, there's no way I will be able to, because the t-distribution is actually the probability of the non-hypothesis. You know, when the non-hypothesis is true, when we are conducting a t-test. And this is the origin. I'm going to start from here now using the Jacobian transformation. We're going to arrive at a t-distribution. Now, after that, I'm also going to walk you through derivation of another important distribution in statistics that we call F distribution. We use F distribution to figure out p-value when we are conducting analysis of variance tests. Analysis of variance tests is also known as F test. You know, for instance, I want to compare means in more than two groups, in more than two populations. Of course, I'm going to conduct F tests that we call analysis of variance tests. And in the analysis of variance tests, if I want to figure out p-value, to take my decision, I need F distribution. So I'm going to walk you through today how do we derive F distribution and how we derive a T distribution. Okay, so let's get started. I'm actually going to make use of the board. And I need you to pay attention because 100% of what I'm going to do today will be on board, be on the board. So like I said, pay attention. Okay, so we want to derive our T distribution, like I said. Okay, and we realize that, this is the origin. Okay, now, this is the origin of that. We are told that Z here, okay, Z follow a normal distribution with a mean 0 and variance 1. So f of Z is 1 over square root of 2 pi exponential raised to power days. Now, Z, so to derive a T, we're told that T equal Z follow normal distribution, Y follow chi-squared, then that is the degree of freedom. So right now, I'm writing the distribution for Z, okay? Now, I'm also going to write this now for Y. Y follow chi-squared with V degree of freedom, F of Y, will be exponential raised to power Y over 2, Y raised to power V over 2 minus 1 divided by gamma V over 2, 2 raised to power V over 2. So here, Z lies between negative infinity and infinity. And of course, Y is greater than 0. Now, T distribution is derived, okay, from a combination of a standard normal distribution and a chi-squared. So t equals z divided by square root of that. Now, if I actually want to derive t, I will need to create an artificial variable first. You remember what we always do. Maybe I'm going to, artificial variable p, okay? The artificial variable p will be equal to y, okay? The artificial variable p that I'm going to, because I can't go from 2 variable to 1, okay? I can only go from 2 to 2, okay? Go ahead.
So v is not a variable here?
Exactly. V is degree of freedom. V is not a variable. V, that's a good question. We're having a V because Y is a chi-squared. In a chi-squared distribution, V is the degree of freedom. Okay? V means degrees of freedom. So it's not a variable.
So is v kind of dependent on y? Is that the reason why v is not a variable?
In a chi-square distribution, we normally have a parameter. The parameter in a chi-square distribution is v. So it's not a variable. Does that make sense? It's v. So now, here, I'm actually going to get the inverses. What would be the inverses? Y equal to p, right? Y equal to p. Okay, now, after getting y equal to p, I want to get z. Z equal to t, okay, square root of, what is that? What is y? So if you take a look at what I have, so this is what I'm actually talking about. You know here I said p equal to y, right? Okay, then I said when I find the inverse, I have y equal to p. Wherever I see y here, I'm actually going to put that p. So I'm having p divided by that. Now, these are the inverses. Okay, you find the inverses. Okay, now, after finding the inverses, the next thing to do, okay, since z and y are independent, okay, since they are independent, okay, then I'm actually going to have g of zy to be f of, let me be using f of y, f of z multiplied by f of y, because we're told that z and y are independent, so I need a joint. F of zy is going to be that multiplied by that. And what is f of z? F of z is this. This is f of y. So here, I'm actually going to have f of zy equal, okay, that multiplied by that, 1 over square root of 2 pi this multiplied by e raised to power this. Then I'm multiplying them. Now I want to simplify now. So minus half into z squared, let me see, here plus y, right? When I say y, yeah, if you combine them, okay, then y v2 minus 1 divided by square root of 2 pi v over 2 and this. Okay? So take a look at that. Let me write the final where we're going. We go in here. I'm coming. We go in here. This is where we're coming. This is T distribution that we want to derive. Okay, now when you take a look at this now, this is f of z and y, because if I want to derive the g of t, I need to first get the joint of z and y the joint of z and y, we're told they are independent. We multiply them, we have this. Now the next is to come back here and get the Jacobian. Okay, we want to come back there. Z equal t square root of p this and y equal to this. Then I want to get the Jacobian. So I need the z, the t, okay, and the z, the p. Then here I need the y, the t, and the y, the p. Okay, that is equal to Jacobian. So the z, the t is just going to be square root of p over v. Okay, the z, the p. Okay, I want to differentiate this guy. Okay, so I can write that as p raised to power half or v raised to power half. So differentiating that with respect to p, I think I'm going to have half Tp minus half this. So which is going to be the same thing as t. Let me see. This one is going to come down. I'm actually going to have half square root of Vp and a t. So here I'm actually going to have the z, the p. Okay. So I'm actually going to have t divided by that. Then here the y, the t. So the y, the t here is actually 0. Okay. Then the y, the p is 1. So that multiplied by that. So from here, I'm having this. This is the Jacobian. Now, if this is the Jacobian, don't forget I get my Jacobian from here. This is the Jacobian. Now I'm going to come here, okay, in the joint of z and y. Wherever I see z or whatever, this is what I'm actually, wherever I see z, I'm going to put this guy. Wherever I see y, I'm going to put that guy, multiply by Jacobian. So which means the g of t and p now, okay? So like I said, I'm going to come here, e raised to power minus half into, what is z squared? Instead of z squared, it's going to be this guy squared. Okay, that guy squared is going to be t squared p divided by v, because this is z, right? It's squared out. Okay, here, plus y, plus what is y? Y equal to p, right? Y equal to p. Okay, now here, p, then y, okay, raised to power that, divided by square root of 2 pi gamma v over 2, 2 raised to power v over 2, then multiply by the Jacobian. Now, look at where we are. Is there anyone want to ask question? We are in GTP now. Okay, this is the joint of a new variable. This is the joint for the old variables. Joint for the old variables z and y. This is the joint for the new variable t and p. Can you see that? Now I want to simplify here now. Okay, so simplify here, p is common. I'm actually going to have p divided by 2. Okay, p coming out. T squared over v plus 1. Okay, and here, p raised to power that. Okay, this guy here, square root of p is the same thing as p raised to power half. Okay, so here we combine with that. I'm actually going to say plus half, p raised to power half. This is a p, this is another p. Then here, this guy is actually going to go down and join this guy. So I'm having divided by square root of 2 pi gamma v over 2, square root this, then square root of v. Now look at my simplification. So finally here, if I here, minus 1 plus half, that would be minus half. Okay, so this is going to be minus half. That will be minus half. Now this is my g, the simplified version of the joint of the new variables. But what am I looking for? I'm looking for g of t. Then I have to integrate out p. Okay, so I want to integrate out P. So my G of T will be integral G of Tp dP, right? So I want to integrate this guy with respect to P. And you know y is a chi-squared. Y is greater than 0. And don't forget y equal to P. If y is greater than 0, P also greater than 0. So here I'm going to have from 0 to infinity. Okay? I want to perform an antiderivative on that. So to perform an I'm going to rewrite that now. Integral. Okay, 0 to infinity. Okay, exponential raised to the power minus P over 2. Okay, t squared over V plus 1. Okay, P raised to the power V over 2 minus 1 over 2 divided by square root of 2 pi. Okay, square root of 2 pi. Gamma V over 2. 2 raised to the power V over 2. Then square root of V dP. Okay, because I want to get my G of T, so I'm performing the antiderivative with respect to that. Okay. Now, I want to integrate with respect to P. Okay, all these guys in the denominator. Okay, there's no P in them, they are all constant. But there's P here, there's P here. So I want to focus on the numerator now. Okay, now I want to focus on the numerator now. Okay, considering the integral is 0 to infinity e raised to the power minus P over 2 T squared over V plus 1 P raised to the power V over 2 minus half the P. I want to consider that because all of this, the one in the denominator, is a constant. I can leave that for now. I want to concentrate on the top. Now here, I'm going to say let the whole of this. Let M be P over 2 T squared. Okay, let M be that. If M equal to that, the P, okay, I'm using substitution method. I'm performing an antiderivative now. I'm going to let M to be equal to that. What is the M, the P? The M, the P is actually going to be C squared over V plus 1 divided by 2. When I differentiate this with respect to P, I'm actually going to have this. So what is the P? What is the P here? The P is 2dm divided by T squared over V plus 1. Okay, this is the P. Now, what is my P from here? What is my P? So P, okay, P equal to M divided by T squared over V plus 1. Now, look at what I got. Then I'm going to come back there and write 0 to infinity, e raised to the power negative. You know, I said the whole of that. I will be M. Okay, instead of P, 2M divided by T squared over V plus 1 raised to power V over 2 minus half. Instead of the P, I'm actually having 2dm divided by T squared over V plus 1. Look at my interpretation. I'm using the substitution method. Okay, you can see what I have. So now, we're here now, right? Now, I want to simplify this. Okay? Now, if I want to simplify this, I'm actually going to have it 0 to infinity, e raised to the power minus m. Okay, m, 2 raised to the power v over 2 minus half, m raised to the power v over 2 minus half, then 2, okay, 2, then divided by, this guy here, t squared over v plus 1 raised to the power v over 2 minus half. You know, this guy 2 raised to the power of that, then this. Then t squared over v plus 1. Now, outside here, let me do 1 divided by the, this guy that I omitted the other time. Okay, so let me put that here. Square root of 2 pi gamma v over 2, 2 raised to the power v over 2, square root of v. Okay, now this is what I have right now. Now I just need to do algebra. Okay, now in doing algebra, look at this. This is raised to the power 1. This is raised to the power. So if I do 1 minus half, that would be half, right? So here this guy and this guy will give me 2 raised to the power v over 2 plus half, right? If you check, let's look at it. This and this, okay? It's actually going to give me this. When you give me 2 raised to the power, if you give me this, v over 2 plus half, I can rewrite that as this, right? So that this is going to cancel this guy here. When you cancel that guy, I'm going to be left with 2 raised to the power half. And I can bring the 2 raised to the power half here. So right now, so this is what I'm having. So 2 raised to the power half divided by square root of this, gamma v over 2, square root of v, then is 0 to infinity, e raised to the power this. Okay, then this, m v over 2 minus r. Okay, now divided. Now, if you take a look at what I have in the parentheses, it's the same. It's like this is having 1. Okay, 1 minus that. So I'm actually going to have this raised to the power v over 2, okay, plus half. Do you see that? Now, the head. I need somebody to tell me this. What gamma is that? You remember gamma function, right? Okay, do you remember gamma function? What gamma is this? Okay, let me write it so that you let me recall from gamma function. Okay, for recall from gamma function. Okay, gamma alpha 0 to infinity, right? That's gamma alpha. So what gamma is this? You know, if this one is raised to the power minus, I had 1 to say gamma alpha, right? So compare that with that. What gamma is that? Go ahead.
V over 2 plus 1 half.
Gamma what? Gamma v over 2 plus half. Good job. Which means you added 1 here, right? Exactly. So now if I want to rewrite this now, I'm actually going to say the g of t equal, okay, and don't forget this guy, okay, I wanted to take note of something. This guy is the same thing as square root of 2, right? Square root of 2 divided by, I want to split this guy, okay, root 2, root pi, okay, gamma v over 2, okay, square root of v. Okay, I wanted to take a look at that. So then here, I'm going to say gamma. You said gamma what? Gamma v over 2 plus half. The whole of this guy become gamma v over 2 plus half, if you recall from gamma function, now divided by t squared over v plus 1 raised to power. I can write this as v plus 1 over 2. Now, I want to simplify. You can see, I want to simplify this guy now. Now, in simplify this, cancel that guy. Okay? Now, if you look at what I have now, from statistical theory, note, okay, if you take a look at what I have here, root pi is the same thing as gamma half. from statistical theory. Root pi is gamma half. If root pi is gamma half, if I want to rewrite this, I'm actually going to write gamma v over 2 plus 1 over 2 divided by, this is going to be gamma half. This is going to be gamma v over 2, square root of v, okay? And this guy can also go up and become, I can have t squared over r plus that raised to power this. Look at that. Look at what I'm having now. Now, when you take a look at this, you will see that, recall that b of alpha beta is gamma alpha, gamma beta over gamma alpha plus beta, right? Now, if you take a look at this, this is like I'm having, if you take a look, if you notice like I'm having gamma alpha plus beta, gamma this plus this, gamma that, gamma that. If you take a look at what I have here. So if this guy equal to this, 1 divided by this guy is the same thing as this. Now, if you take a look at this guy, right? If this equals to this, and 1 over that is that, then this guy here is 1 over b into 1 over 2 comma v over 2, this guy here. So finally, if you take a look at that, okay, now when you take a look at this guy now, is this. Is this. b into 1 over 2 comma v over 2. You know, you can say 1 over that. So 1 over that, if you want to come from beta function, okay, you know this is a recall from non-integral definition of a beta function. So that's what I'm recalling. So now this guy is this. This guy is that. Anywhere in the world, this is a distribution. This is a T distribution. So we derive our T distribution from that. You can see this mathematical, highly mathematical. You know, we call this theory of statistics. Go ahead.
How do you know which one is alpha and beta?
How do I know which one is alpha and beta? It could be any of them. It could be any of them. It doesn't matter because you are adding. You know, commutativity. When you are alpha plus b, a plus b is b plus a.
But wouldn't the interpretation be different?
No, it's going to be the same because when you are adding, whenever you are adding, okay, it's allowed. So b of alpha beta is the same thing as b of beta alpha. So provided you are adding, okay. So now this is how we derive. I'm also going to walk you through how we derive the F distribution as well. Let me quickly show you this.